Dear students, in today's session we will discuss a second type of problem in chi-squared. Okay, so look at the problem. A milk producers union wishes to test whether the preference patterns of consumers for its products is dependent on income levels. A random sample of 500 individuals gives the following data. So you have, that is low, medium, high, and then product preferred, that is A, B, C. Okay, so the values is given. So according to the income level, the patterns, that is the product preference patterns are also given in this particular problem. Okay, now the question is, can you conclude that preference patterns are independent of income levels? Use chi-squared value at 5% level of significance. So using 5% level of significance, whether we need to test the goodness of it, of this particular problem. Okay, so we need to check whether the preference patterns depends upon the income level. Okay, so what is the first thing that we need to do in this chi-squared? Just like any other problem, first thing that you need to do is you need to formulate the null hypothesis and the alternate hypothesis. So here we are asked to check whether this product preference is depending upon the income level. So we can say that our null hypothesis is preference patterns of products and incomes are independent of each other. So definitely alternate hypothesis will be preference patterns of products and income are dependent, right? So let's write it down. So here we have our formulated null hypothesis and alternate hypothesis. So that is preference patterns of products are and income are independent is null hypothesis, and alternate hypothesis will be preference patterns of products and income are dependent. Okay. Now what you need to do is, in this particular question, as you can see here only the observed frequencies are given, right? Only observed frequencies are given, but the expected frequency is not given. Now you need to find out the expected frequency, and definitely you need to find the degrees of freedom. And here you can see that in this particular problem, it is given in categorical manner. That is low, again for product A, the frequency is 170, B 30, C 80. So this is given in a tabular form, right, in rows and columns. So we don't know the expected frequency, as well as how do we calculate the degrees of freedom, that is also given in a tabular form. So for that you have two different formulas. Now we will see how we are going to calculate the expected frequency as well as the degrees of freedom. Okay, now for that you need to write it down as such, just like how it is given in the question. Low, we have all the observed frequency. Now you need to calculate the total frequency of each row and each column. Okay, that means you need to tabulate this. 170 plus 50 plus 20, that is for product A. The total frequency will be 240. Then again 30 plus 25 plus 10 will give you 65. Then 80 plus 60 plus 55 will give you 195. This is the total, that is the column total. Similarly, you have to find the row total. Okay, so for low, that is for when the consumer's income level is very low. So what is the total frequency? So 170 plus 30 plus 80 will give you 280. Then 50 plus 25 plus 60 will give you 135. Then 20 plus 10 plus 55 is going to give you 85. So now we have row total and column total. Now just calculate whether these two things are coming together, like getting balanced or not. So 280 plus 135 plus 85 will give you 500. Again here 240 plus 65 plus 195, that is also giving you 500. So total number is 500. Fine, the total frequency is 500. Is that clear? So we have row total, now column total. Now there is a formula for calculating degree of freedom. Now degree of freedom is column minus 1 into row minus 1. Okay, this is a column number and this is the row number. Here you can see there are three columns A, B, C. So C will be 3, right? Then how many rows are there? Low, medium, high, again 3 rows are there. So you can write the degree of freedom is equal to 3 minus 1 into 3 minus 1, that is 2 into 2 will give you 4. So the degree of freedom is 4 for this particular question. Okay, now we need to calculate the expected frequency. Whenever a problem is given in this manner, that is in a categorical form, in a tabular form, expected value or E is calculated with this formula, that is row total into column total divided by total frequency. Okay, row total into column total divided by total frequency. That means for the first frequency, say for the first observed frequency, that is 170. So what will be the row total of this thing? The row total is 280, and for 170 the column total is 240. So 280 into 240 divided by total frequency, that is 500. That will give you the expected frequency of the first observed frequency, that is 170. Is that clear? Again, for 30, if you take 30, the row total is 280 and column total is 65. So 280 into 65 divided by 500. Similarly, for all these things, that is for all these frequencies, you need to calculate the expected frequency. So let's see how we will do it. So I have constructed a table. So you have the observed frequency, expected frequency, O minus E squared, and O minus E squared divided by E. Okay, so I have written down all the frequencies that is given in the question. Now in the question you have these many frequencies: 170, 30, 80, 50, 25, 60, 20, 10, 55. I have written it in this order. Okay, so I am going to calculate the expected frequency for each observed frequency. So for 170, what is the row total? Just like how I told you before, the row total is 280. 280 into, again, column total will be 240. 240 divided by 500. So that will give you 134.4. 134.4 will be the expected frequency of 170. Then again for 30, similarly 280 into 65 divided by 500. This will give you 36.4. Then 80, that is 280 into 195 divided by 500 is equal to 109.2. Then 50, for 50 it is 135, that is the row total into 65, column total divided by 500. This is going to give you 64.8. Okay, so for all these things we have written down. For 60, 135 into 195 by 500, 52.65. 20, 85 into 240 by 500 equal to 40.8, and 10, 85 into 65 by 100, 11.05, and 55, 85 into 195 by 500, 33.15. So this is like you are multiplying, that is row total into column total divided by total frequency will give you this expected frequency value. So for all the frequency you have calculated the expected frequency. Now everything remains the same, that is O minus E, that is observed frequency is 170 and this is 134.4, right? So 170 minus 134.4 will give you 35.6. 30 minus 36.4 will give you minus 6.4. Okay, then again 25 minus 17.55, that is 7.45. 60 minus 52.65, that is 7.35. 20 minus 40.8 minus 20.8. 10 minus 11.05, that is minus 1.05. 55 minus 33.15 will give you 21.85. Now this value you need to square, that is 35.6 squared, that will give you 1267.36. Then minus 6.4 the whole square will give you 40.96. 29 this is minus 29, okay, minus 29.2 the whole square will give you 852.64. okay, so here minus 29.2 the whole square is equal to 852.64 minus 14.8 squared to 19.04. 7.45 squared 55.5025. 7.35 squared, that is 54.0225. Then minus 20.8 squared 432.64 minus 1.05, that is 1.1025. Then 21.85 the whole square is equal to 477.422. So you have this column filled. Now again you have to divide this with the expected frequency, that is 1267.36 divided by 134.4. So that will give you 9.43. Again 40.96 divided by 36.4, that will give you 1.1253. okay, then again 852.64 divided by 109.2. So that is 7.81. Similarly, for all these things, you need to divide it with the expected frequency. Okay, so I have written down all the expected frequencies. Not expected frequency, O minus E squared divided by E value for all these things. Now what is the next step? Next step is to sum up all these values. So finally you will get 51.0401, that is 9.43 plus 1.1253 plus 7.81 plus 3.38 plus 3.163 plus 1.026 plus 10.604 plus 0.0998 plus 14.402. So you will get 51.0401. So this is your chi-squared value. So you need to write the chi-squared value as 51.0401. Okay, this is the calculated value of chi-squared. Fine. So once we got the chi-squared value, what is the next step? The next step is to calculate the tabular value. Now you need to find the tabular value. In the question, it is given that now you have to find the chi-squared value at 5% level of significance. So for 5% level of significance, and we calculated the degree of freedom as 4, correct? So for 4 degrees of freedom at 5% level of significance, what is the chi-squared value that we need to calculate? So from the table, we can see that the critical value of 5% level of significance with 4 degrees of freedom is 9.49. So chi-squared table you can see at the back side of the logarithm table. 0.05 level of significance and 4 degrees of freedom, you will get 9.49 as the chi-squared value. Now this table value and this is the calculated value. Calculated value is 51.0401 and tabular value is 9.49. So which one is lesser? Table value is lesser. That means the calculated value is greater than the table value, which means that we need to reject the null hypothesis. Okay, so finally we can write our inference. So finally you can write the inference like this, that is, as the calculated value, that is 51.041 is greater than the tabular value, we reject null hypothesis. Therefore, preference pattern for products and income are dependent on each other. That means we are accepting the null hypothesis when we are rejecting the, we are accepting the alternate hypothesis and we are rejecting the null hypothesis. Okay, I hope this is clear to you. This is same as any other chi-square test. The only thing is we need to calculate the degree of freedom and expected frequency using the given formula. That is, expected frequency is row total into column total divided by total frequency, and degree of freedom is column minus 1 into row minus 1. Okay, so I hope this is clear to you. Thank you, students.